NGS was getting into biology and made a big difference for biology. When Human Genome Project, when I worked, it took almost 20 years, actually, 10 years, but finally after 20 years, we could show that here is the first human genome. Now the machines, what we have, we can do it in 1 day's time, and it can also be analyzed. But one thing was happening was, while NGS technologies were moving, strangely, biologists were moving away from NGS. See, when crystallographers started crystallizing the proteins and gave the structures, we biologists many a times look at the structures, but it's only a small part of our thesis or our research paper. It was a domain outside us, right? We might go and mutate those amino acids which are closer to the active site, but it was basically going out of us. So, so we wanted to develop Commander. You will soon know why the name Commander in just 2 slides. For short reads or long reads, can we empower the biologists to do NGS analysis, to understand first the NGS data, right? Many of you might be outsourcing the data to some service provider, or maybe you outsource it to a sequencing center, academic sequencing center, or you might have a sequencer and you do the sequencing yourself. It's always a mystery, right? You always have
Okay,
IT professional. Can you please mute yourself? I think someone from. Thank you. Um, so that is the dream. So then we developed, designed it, and developed it in Genotypic. We started almost 2 years ago. I have my colleague who's sitting right next door, Mr. Anand. He was instrumental in coding this out. And then KK Kamala Kannan is also there. We have a few more of the teams. I think end of the talk, I'll be able to introduce you to them, or introduce them to you. So where did we start? It started in 1998, and then you can see by 2021, it has become all what we call as DIY, or do it yourself. Why do you want to wait? Why do you want to make DNA, do QC or RNA, send it to someone else, and then someone else send you data, and then you have to wait for someone else to analyze that data? So last year we launched Commander. So we have more than 50 people now using Commander worldwide. I think it almost reached 100 now. It's fully customizable. You want to sequence SARS-CoV-2, you can use it, starting from raw data to end data. Actually, I'm talking everything because Commander takes very little time to analyze. See, you might have heard, no, Kannada government or Delhi government said, we have started sequencing. It will take 72 hours for sequence data and 72 hours for analysis. I don't know why 72 hours for analysis. Maybe even when someone uses normal tools and do everything, it should not take more than 12 hours. I'm now talking about it will take 12 minutes. Right? So this is where we are. So what is the major issue with the command data analysis using command prompt? The limitation is, firstly, you have to depend on a bioinformatician. See, a person who did the RT-PCR can be the same person who can go and do the analysis, but they don't have access to server. There is coding. So this coding is something which no one wants to do. And there is not one line. You have so many lines to write. And it also becomes very difficult to troubleshoot. Something goes wrong, you have to go back to an IT guy. Right? So there is multiple tools you may have to use. It's not like an Excel file. You open, do something, and you get the results, make charts and all. There are multiple tools developed by multiple people around the world. There might be a Python code for trimming. There might be another code. There might be 5, 6 tools which you can do alignment to create a BAM file. You have to convert into sorted BAM file. You have to make a VCF file. You have to take the BAM file and create a consensus file. There is a FASTA sequence of all the reads put together for that sample. Then you have to take this and go to different places like Usher, UCSC Usher or Nextclade. There are so many places. Now you have to go Pangolin and paste this data and then find what it is. So finally, can you analyze like a boss, like what Rajinikanth says? No, what limitation? Where is the limitation? Sky's the limit. So we want to bring that sky's the limit to all of you. You don't need to know command line operation or how to use even a Linux machine. Actually, I'm presenting from a Linux machine. Apologize. That's why whatever I made originally in PowerPoint on Windows is showing up slightly differently on the uh, Linux machine. So how can you sequence like a boss? So what are the things a biologist should know or should be capable of? First one is, can you do base calling and demultiplication of, see, in Illumina it's BCL files, right? Short reads or long reads, can you do that? Can you do quality control and quantity also? My genome size is 30 kilobase, that's a SARS CoV-2. So if I need 1,000 times 1,000x coverage, I should have 30 MB of data. How do I find if I have 30 MB of data or not? I will show you. You can also find it yourself. And then is there any contamination? Maybe you sequenced oral metagenome. Maybe there's contamination from human DNA is there, right? How much is human DNA? And then you always have, everyone is worried, particularly if you're using Illumina sequencing. Maybe barcode, this barcode has gone to that barcode. Even if there is a deletion in one, the contamination from the other barcode can actually spoil the data. What could be Omicron can be shown as a Wuhan line if there are deletions. So how will you know it? So there are many things. Even merging FASTA files or FASTQ files. Maybe 2 runs you have done. One is today, one is tomorrow. You have to put them all together and do the analysis, because after analysis you cannot merge. You have to do it before that. So there's hazard things one has to do. The final bottom line is, can you really take control of your data? And can you do it yourself? This is the requirement, and this is what Commander can help you. See, you will still need a bioinformatician, but maybe just when you get started, that we can do it from online, we can support you as well. Or if you have an in-house bioinformatician, you need her help or his help to initially to get started, make sure files are there. This is like someone to teach you driving or get your motorbike started, but you don't need a mechanic every time with you whenever you drive a motorbike, right? So this is not only made for nanopore, we indeed made for nanopore technologies. And it can happily work for Thermo Fisher, MGI, Illumina short read data, or MGA short read data, packed by your long read or the circular reads, which are much shorter. It can work with everything. And of course, uh, Oxford Nanopore Technologies. I put Oxford there is because Oxford Technologies, as you know, is going everywhere. We have installed in, I think, 25 RT-PCR labs. So the folks in the RT-PCR labs are good molecular biologists, but they have never done NGS library preparation. nor they have, many of them have ever done a NGS data analysis. So if I'm going to help the government sequence SARS-CoV-2 instead of sending to central labs, which takes quite a bit of time, paperwork, and then they are doing some analysis, and these people don't even know what they analyzed. So if they can do start in the morning, get not just the data in the evening, can they get what is, whether it is Omicron, Delta, or what, right? And the people who have done the RT-PCR, we empower them. That's why we started with Oxford Nanopore. Now it's available. Commander is available for everything, for every platform, every sequencing platform. You can even put Sanger data also. I didn't put Sanger here. You can put Sanger data also. So what and all it can do, right? It can do, as I said, it can base call, it can demultiplex, it can calculate sequence quality, quantity, everything. So now I will take a break from the presentation and then go and show you directly how data looks and how you can analyze the data. So now I'm going to my desktop. So I think you can see the folders. Believe me, Commander can take Illumina data, Iron Torrent data, Oxford Nanopore data, PacBio data, and analyze all of them. Doesn't matter for Commander, because what are we going to do? It's going to align the reads to the reference file, which is that Wugan reference file. It's going to create a BAM file, and then it's going to create a consensus. And another side, it will create a VCF file and look at what are the base differences. See, because whenever you create a consensus, if you have a doubt, the base becomes N, right? Or if A is 100 times, G is 10 times, it will be called as A. Whereas in a VCF file, you can even put that A is 90 times or A and G is 10 times, right? So I will show you how a typical data looks. Let me go and show you a ONT data. So here is a FASTQ file. See, now I'll give you a clue. See here, the size of this FASTQ file, if it is zipped, right? Or let's say a FASTQ file which is not zipped. Let's say this is 5 MB in size. This means the total data present here is 2.5 MB. Why? Let me open this. See, it's always FASTQ file, as you know, starts with @ symbol. And you can see the DNA sequence, and then here is the quality score, right? The quality score also. So the 50% of the data is quality score. So I can go and happily say, this is almost 6 MB, only there is 3 MB data. So when there is a 30 MB virus, a 30 GB virus, I need 30 MB to say it's 1000x. So it's only 100x coverage. But since this is a zipped file, when you zip it, it usually zips almost 6 times. So it's maybe 180x coverage is there. So like this, you can go and look at each one. Iron torrent data. Also, you can see how the data looks, right? Sometimes no iron torrent data, the length might be small in some of them, long is long in some of them, right? That also works like this only. Same @ symbol, and then the plus symbol, and then the quality. So here again, any FASTQ file is half the size, half is FASTA, half is the DNA sequence, rest half is quality. So this is how the data looks. Typically it won't look like this. You'll have barcode 1, 2, 3, 4, 5, 6, 7, 8, 96. Just for demonstrating to you, I've taken Illumina, ION, ONT, Oxford Nanopore data, and also PacBio data. See, I'm telling all this because Commander works much faster than I speak. So let's go to Commander. Username Genotypic. I'll tell you a secret. The password is Commander. So here's Commander. It's almost like if you can do a Google search, you can start using Commander. So let me go and get started with this. See, in the Commander toolbox, you can find lots of things. Primary analysis, you want to base call, you can base call. If you have done some PCR with some barcodes on both ends, custom barcodes, you can demultiplex, right? This is base calling FAST5 files. This is nanopore files, or BCL file is Illumina file. Even before you go and make a library, also load the library, you can look for barcode collection. You can trim long reads, you can trim short reads, you can do even blast. I will show one of them. One simple thing, I will show you how you can split a file. For example, the same file. See, I take a, oh, sorry, other locations. Let me, oops. See, I think I have to 1 minute. I'm just joining from the another. See, you can open multiple versions of the Commander. So I'm going here, primary analysis, secondary analysis, file handling. I want to split FASTA files. Okay, so let me go to one minute. Let me also go here. Yeah.
You can go to desktop.
Which one?
Desktop.
This desktop? Okay, thank you. It was going into my computer's desktop. Okay. Where is in the desktop? This is COVID analysis. This FastQ I can use, right? Okay, I'll use the same file. Thank you, Anand. So this is Anand, by the way. Okay. So I'm going into one of the ONT files. I'll open this file. So it will show how many reads are there in this file. So I can divide this file into, say, I put 400 files, 400 FASTQ in one page. So if I do this submit, in 1 second, is chopping this file into multiple files, which is 10 files, and put them on desktop. So I can go here, desktop, file, patients. I'm sorry. Let me go back here. So this has put on my desktop. Yes, put. Okay. This has put in this desktop. Anand, if you're listening, which desktop he has put? I'm sorry, I opened two desktops. Which desktop is put? See, it shows, it says Raja Home Desktop. Maybe. ONT folder. Okay. He is started from the ONT folder. But anyway, let's check this out. I think in this command. Okay. So let me start this one, original one, SARS-CoV-2 analysis, and then I'll go back and show. Okay, folks, I'll uh, start the analysis, and then we can go back and see this other things. So now I'll go and start this analysis and then go back and show you how to cut the files and all. So for COVID analysis, I'm going to show this, what is called as general variant calling pipeline. This means he's just going to take the files, the FASTQ files, align it to the Wuhan reference, create a BAMP file, do the variant calling, create consensus, do the whole pipeline, what might take several hours for someone to do, and then create a report also. So let me go here. So the sample which I'm going to select is samples directory. I'm going to go with SARS-CoV-2 data. So I have multiple data, the same files which I was showing. So I'm choosing that. And then you have to choose how many threads you want to do. It depends on the server you are sitting. Most of the servers you'll have sufficient number. If you have 48 cores, means you'll have 96 threads. So I'm giving 50 threads and saying submit. Wait a minute. I have to redo this. It happens sometimes. I'm going back. COVID data analysis, pipeline, general variant calling, select. Desktop. I'm choosing that, and maybe I give something like 40. Again, it's going. Anand, if you're around, I think should I give lesser number of should I give lesser number of cores to run? See, maybe
someone is running.
Okay. Or I'll run it from my computer. That's easier. So I'll just give C. Yeah. So maybe I'll run it from here.
From new can you permission is
Okay. Guys, folks, just give me a minute. I'm restarting the.
Can you go to that folder? Initial folder. Go to desktop. Open this one. Go down.
I think this one.
Go to terminal.
I think these two I will remove. Maybe this is.
No, some condition is good. Let me check.
Yeah.
1 minute.
Okay. Meanwhile, I'll show them how to do the file. 1 minute. Meanwhile, I'll show you how to run the. So I'll quickly show you how to split files. So I have in desktop, I'm going to take one of the FASTQ files. I'm sorry. So this file contains something like 82,000 FASTQ files.
मैम अभी क्या बिजनेस किया है आपको मैसेज जाना है
So I'm asking him to split the file with 10,000 files, 10,000 reads per file. So see, you can see he has already cut them into same file name, that 9_1. So he is giving me totally 6 different files. You can see the last file is slightly lower because it was not fully totally 6,000 files, right? So in a minute, he can cut the files. Now I can give these files to someone, or I can take these files. I can take these files and merge those files also. I can go to the same thing. See, I can take all these files, 6 files selected, and I can merge them into one file. So these are very simple operations, but if you really look at it, to take all these files and someone to cut and paste and put this together, such very simple things can also be done. You can also do chop reads. For example, you want here, you want to chop the reads. I can take one file and then say, I want, see, I'll take a smaller file from here, 12 MB file. I'm sorry. I can take a smaller file which contains 8,000 something records. And then I say, I want to trim. See, in nanopore, usually it's 50 bases. If you trim, the adapter is gone. So I can trim forward or reverse or both sides. So you can give one side or both sides and then say trim. Let me restart him. See, if the files have any issues, usually it will not, unlike Windows, the whole thing will not crash. It might quit and you can restart it yourself. So file handling. that is merging files file. This is chopping file. You can take an input file. This I'm running from my computer laptop. I think it's slightly larger. So I'll just put 50, trim only the forward side and submit. Yes. So now he has completed, and you can see where he has outputted it. So he has outputted in the desktop folder. So I can go back to the desktop, and here he has put the file after trimming. So these are large files. I think it will take time to even open on smaller computers. You need not even open. Okay. So I'm closing it, going back to Commander. Um, so what are all the file, the, apart from the COVID data analysis, you can see long reads variant calling. Here, you can take your reference. You can even use PacBio data or Nanopore data and do it. Yep.
You have changed the output location for that. You launch from Gori.
Yeah, this is launched from there.
So you see, given location where you do not have permission, you have
Okay.
to change the location from here.
Where?
This folder, I think.
1 minute, I have to change.
Yeah.
Okay. This one.
Oh, above. Yeah.
Okay.
No, it's
Okay. Thank you.
actually you don't have
Yeah.
permission. That's why it's.
Yeah. See, one of the things Anand came and told me, and when we were getting MGI data, just for showing you, I have never analyzed MGI data, by the way. MGI SARS CoV-2 data, they sent me today. So I changed the file location to MGI, that location. So sometimes in Linux, those things happen. So you have to be careful here. See, output location, where it is, you have to keep it only where you have permission. I have given a location where I took it from, which is from a server. So this won't allow me to write there. That's why it was crashing. So let me quickly show you this, what and all we can do. You can do variant calling, and then whether nanopore or PacBio, this for long read, you can select. And then you can choose the reference. It can be SARS-CoV-2, it can be human genome, never mind. So it will do the port chop, means the ends, it will chop. And then it uses Minimap and SAM tools and BCF tools. So this will call create BAM file, create sorted BAM file, create VCF file, create a consensus, and you will close. This is the same thing which we are also using for uh, COVID data analysis as well. So let me close this version and then go to one more time. I will go here. Okay, we are all set to start the COVID analysis. So I'll show you how easy and simple it is. I spent some time to show you what and all it can do. So I'm going to use the general standard COVID variant pipeline, calling pipeline. This is the same thing used worldwide. Worldwide, the same thing is used. Arctic and Midnight are mostly used by Nanopore. That too, when early times, when it started with the fast 5 files, that is the unbase called files. Now that live base calling is available in Nanopore, uh, everyone is switching back here. So the samples directory is this. I'm choosing the samples directory, and I give 50 threads, and I'm double checking once mistake is done. Yeah, it's going only to my desktop, and then I'm submitting. So now what he is doing is, you can see what commander is doing. Okay, he is firstly doing a BAM based. See, he's still starting. You can put, you'll see ticks, right? So, for example, in Illumina, there will be two FASTQ files, read one and read two. It has to be merged. So that he is doing. See, that is merge FASTQ files, right? And then you have to create statistics also. How many reads are there? What is the length? And then he is doing the alignment, right? BW alignment. And then he will be creating the SAM file to BAM file. And then he'll create a sorted BAM file. See, the sorted BAM file is required if you want to open the alignment or IGV viewer. So file by file he is doing, that sample by sample he is doing. You will be surprised. Even before I show something else, this he would finish. So I think I'll go back and show you what do we have here, desktop. See, this MN3, MN4 are from this one, MGI. These two are from MGI. That's the our folks, we downloaded only just now. MGI folks gave. So these two are, we can even check it, how it looks. Then we can find it. Yeah, looks like only MGI files, MGI data. These are short read data. Let's see how it comes. I've never analyzed that before. First time I'm doing it. So you can see he's finishing. See, after you can see he's generating consensus. Oops, it's already moved to the next sample. And then generating FASTA, predicting lineage. So he's doing one by one. Since we have some 12 files running, he's doing. Let's give him that 5 minutes time to finish, commander to finish, and let me run one more of this. I'm opening one more commander to show you something very important. One of the most important thing in, I'm sorry, anything is sequence QC. You want to quickly know what is there in that sequence, right? How many reads are there? What is the length of it? What is the quality of it? So all of them, let's do it now. See, I'm opening a folder with the FASTQ files. There are totally 8 files are there. I'm submitting. So this is now creating a statistics for these files. And then we can go and open. See, he already says where he has put. So same issue we had, like all of you might have, same name. So he has put GT analysis, the date, and a random or a sequential run ID. So here is where I have to go and look for it. So desktop. COVID, and see here is GT So this can be opened. So let me show you. So for different barcodes, how many reads are there in each one of the files for FASTQ files? How many bases are there? What is the average read length? What is the longest read length? What is the shortest? See, these are all nanopore data. You can already see. Because in Illumina or MGI, you will never see 5 kb reads. Or forget about 5 kb, 26 kb and all, you can never see. So what is the highest Q score, lowest Q score, average Q score, first base, last base, what is the GC percentage? So almost everything is given. So this makes you now comfortable. Yes, each one of the FASTQ files are good enough for doing analysis. So this is very important because if someone dumps you with huge number of files, you need to see within few minutes whether it's Illumina, Nanopore, or PacBio, MGI, Thermo. You need to know what is the number reads, bases, average. This it can do very quickly. Commander can do this very quickly. Now let's go back to what's going on here. Okay, guys, COVID analysis successfully finished. 3 minutes. It took 3 minutes for, I'm going to show you the data, but I'll tell you, it took 3 minutes for, I think this is what we took. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For 13 samples, he has finished in 3 minutes. So if we have 96 samples, maybe 10 times, even if I put 10 times, it should finish in 30 minutes, maximum 30 minutes. You don't need 72 hours to do analysis. Even that 30 minutes is already too much. We don't usually do it that long. So now let's go back and see where is this data. Okay. So this is SecQC analysis. Here is our data. All the data is here. I don't know what you want to see. I usually want to see this data. This is one file which will give you what exactly it is. You see, these are the different samples. As promised, these came from different, see, these two are, by the way, MGI reads. Our folks didn't know. They were short reads. They put it at MN3, MN4 and all. These two are MGI reads. Today we got, I never analyzed it before, ion reads. These are ONT, Oxford Nanopore reads. So you can see, I'm sorry, this is, let me reduce this. Okay, okay. So you can see this is sequence coverage. This is what people always ask. What is my X coverage? It's a 750X coverage. And this is genome coverage. There is 30 kb viral genome. What percentage of the genome is covered? 88% of the genome is covered. I think these are Illumina we downloaded from someone's upload to the NCBI database. I think they used the primers were old primers, I guess. And you can see here, this is the MGI data. This is ion data. These are ONT data. We have seen that typically in ONT, even if I have 50x to 100x coverage, I can cover 99% of the genome. It all depends on the primers. See, these primers were all optimized by us. We optimized for alpha, beta, gamma, delta, and also after Omicron came, same set of primers can sequence everything, PCR amplify everything. And then these are PacBio, right? So you typically need 1000x is high, 100x is low, somewhere in between. I'll tell you why. But here, this is sequence coverage, this is genome coverage, and this is lineage prediction. Okay. So this is AY5, this is a Delta variant, this is also Delta variant. So this is an Omicron, right? So you can see here, Delta, Omicron, See, this BA2 is what is more and more coming up in India, right? This is Scorpio call, but the other one, which people still use, the pangolin, clade. So you can see here, delta, delta, 20B, 20B, Omicron, 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 again two deltas, alpha. I think PacBio data was very old data, I think. So we could see that within a very short time, you can get to this table. This is the most important table. If you don't want something, you can delete those, what do you call, no, some of the columns, but it's important to see these columns because if something goes wrong, you need to go back and look at it. Why, what alleles, right? How many alleles were replaced? How that lineage assignment was done? Everything you can see. Now let's go and see what else we can see. See, this Nextclade and Pangolin also given us separate files. See, if you don't use this, what will you do? I will go and show you. What will you end up doing? Okay, I'm sorry. Here. Reports. So I will go and show you report. See, let's take this report I never seen. So I'll see it. So this is a report for the MGI data. See, MGI maximum read length is 139, minimum is 35, average is 87. So you can see this is the genome coverage, how the genome is covered. See, there is one place some PCR product did not work. As you know, these are all PCR products which are put together for sequencing. And then you can go and see the amplicon coverage. So you can still see some amplicons worked well, some didn't work well. But believe me, this is more than good enough. See, the lowest amplicon, number 2, itself has given 257x coverage. Right? That's more than enough. See, we are doing all 30x coverage, right, normally for base calling. So consensus file is created. You will know how many non-ATG characters are in the consensus file. See, these non-ATG characters come because of two reasons. If there is no coverage, sequence coverage in any region, it will put an N there. Or maybe some reads a G, some reads a C, and it don't understand what it is. Also, it can put N. And then this is variant annotation. How many are missense? How many are synonymous? How many are in intergenic region? That block is done. And all the non-synonymous variant, a table, it creates a table. So you have here, you can actually jump and go there. So from here itself, we will know. See, this is not Omicron. See, there is just one mutation in the S. This might be some early variants. And then lineage prediction. See, this could predict only it has B1.2, which means there is not sufficient variance here from the Wuhan to call it anything else. I think this is a early alpha variant. So one can go and look at each one of them. Sorry, I don't know where I was seeing. Here. So one can go and look at these are the reports. Thank you. That's nice. So one can go and look at different reports. For example, I can go to ONT and look at the report, this Oxford Nanopore data. You can go and see. See here also you can see these are all because early times we were using certain primers which we later on optimized going down. So you can say 1x coverage is 99, 10x 96, 20x this much, and how the amplicon coverage looks. And each amplicon, what is the X coverage? Right? Is good enough. Good enough. Even the bad ones are having 61x coverage. and then different variant annotations. What are the non-synonymous variant? See, already I can see lots of mutation in yes. This is probably a Omicron. Yep, see, it's a BA2 Omicron. So here is one report comes, and then the table which you saw, right? So this also gives this. And now let's go to the most important stuff is, I'm sorry, see here, consensus file. For each sample, consensus is created, and all sample is also created as a single FASTA file. You can take this FASTA and go to your favorite place. Let's go to, see, most people always goes to Nextclade. We can go to Nextclade. SARS CoV-2. You can put the text, run. So Nextclade will run. See, technically you need not go because Commander keeps the most updated data in the database. So you can use Nextclade, you can use COG, UK, Pangolin. You can run it here, or you can go see Nextclade is running. See, let's see here itself. See, he already giving. See, whatever more or less we found there, it's what he is going to show. Rather, exactly the same regions he'll be showing. See, the same three ONTs we found Omicron. No, see, he's finding Omicron. 21K. See, here is Omicron. Here is Omicron. And the last two pack bios were alpha. He's also finding alpha. So what people do is, even though they trust Commander, because it's running three different ways to find out what it is, and a table is also given, but people do go and run these, either go to Nextclade or you can go to UCSC. Usher also gives you the um, phylogenetic analysis. So see, already internet is slow. So when you have Commander, you need not worry about internet speed or something like that. Sometimes that server itself may not work. So maybe few of the samples, what we saw, no, this from this consensus, all sample FASTA, you can just take few of them and run it also. See, in the FASTA, you can actually see there is N starting, some N's might be there, because you can never put a PCR primer right outside the virus, no. So end also you might see N's. See, in between also you can see N's, right? These are all, see, we put N's when the coverage is low, very low, less than 3, it will become N. When the coverage is low, but still we can call bases, it will be called in lower case letters. So all these programs can understand. See, the Illumina ones we saw, no, some of them they read, the PCR products did not work well. So that's what we are seeing there. And if you go to the end also you will be seeing the, I think there is a way to go to end. Yeah, if I go this way, yeah. So you can see most of the end. You will see ends coming up in most of the end also, because those regions, depending on the PCR primer and sequencing chemistry, you might be missing it. So, folks, that's what I wanted to show you how, in very simple ways, 3 minutes for 13 samples, maximum 30 minutes, maximum 30 minutes for 96 samples, you will get full reports. And obviously, everyone want to see this kind of a table for each sample, what it is. You can cut whatever you don't want, but we keep everything because you need this lineage, you need this Scorpio core, and you need this clade information from next clade. All these three will be needed. You will definitely need here what is the sequencing X coverage, what percentage of genome is covered, all these things you need to know. And very importantly, now we are bringing up something new is maybe there is a new mutation, maybe there is a new one coming, right? Maybe BA5 Omicron with additional mutations coming. So we are planning something to show that if it doesn't belong to any clade, can you find something where he actually lies, right? And if there are enough for them, no, you have to have enough samples because one sample might be an anomaly. We have 4 or 5 samples showing something strange. Then we can try to say that, hey, this is a new, potential new. Technically speaking, these things are all potential new of those days. No one actually probably tried to expand it out. And in Nextclade, the same things you might see it as a, they might have called it something, right? See here also, see, they could not go too much deeper, even though there is enough X coverage um, on that. So, folks, I'm happy to go back and start this slideshow. Base calling to blast. Anything you want to do, you can do. Actually, the whole SARS CoV-2 analysis is not even 5 minutes, right? So, what else you can do? You can do many things: file handling, different applications. Help is also on click. This is what I showed you, how to get this report generated in one click. So this basically means an RT-PCR lab molecular biologist, a good molecular biologist. See, RT-PCR labs people become good molecular biologists very soon because unlike anything else, no, they get samples from CT14 to CT39, barely present to hugely present. They risk their lives to uh, do the PCRs. Right? So they, within, sometimes it won't even take weeks, it might take even days. They will immediately, because they understand the whole process easily. And the whole protocol of library preparation and PCR for library preparation are exactly the same. There is nothing big. So this is what I showed you: genome coverage, amplicon coverage, analysis report, what are non-synonymous variants. And yes, by the way, we found one of the first Omicrons were run out of, came out of Commander in India. And who are using it? See, I have quite a few people who gave RGCB and also the other lab in Trivandrum, NIV, um, from Haryana, Punjab, the very first lab in Haryana, and I think the only sequencing lab in Haryana was set up by us, and they use Commander. So a lot of people are using Commander, including um, RGCB, NIRI, NCBS also used Commander for it. NIV Pune, Banaras Hindu University, Shivnadar University, ICAR, this for agriculture. I think around 100 commanders are working. You might have seen Rajinikanth movie, no, Robo. So we can send these robos everywhere. So whole NGS data, even if you have old NGS data, you got it from somewhere or you did it before, this is something you can now take it up and reanalyze it.